Hi there, knife people, hello lady and gentlemen. Today we're getting into yet another Ozark Trail entry into the world of knives. And I found it at my local Walmart. They are available as we speak. This is Ozark Trail Elevation. I'll just start calling it Elevation. Elevation is a push-button lock knife. I'll get into some of the details about this lock in a little bit. Some people call it also a plunger lock. And it has a blade made out of Swiss steel called Sanvic 12C27. And we'll talk about steel as I test the hardness. And by the way, I will test the hardness of this blade, as well as resilience of the knife's construction, as well as the toughness of some of its elements. If you are a brand new knife enthusiast just starting out on this journey, I apologize in advance if some of the topics I discuss get a little too technical. Don't hesitate to ask me any questions because I read all your comments and I respond to a lot of them. And if you are an advanced knife enthusiast and some of the parts seem to be boring to you, there's a way to skip through them intelligently by clicking on Ask button at the bottom of your screen. And in there you will find summary of the whole video with timestamps for each individual section. Courtesy YouTube's AI. The era of the button lock or plunger lock came with this knife. This is Protect Malibu. Protect is a US company. All their knives are made in the United States. And they're famous for their out-the-side automatic knives. Out-the-side automatic, you push the button and the blade, which is spring-loaded, flies out into the open position. What they did a few years back, 5 or 6 years ago, they took the spring that ran the blade out and they slightly modified the plunger and the blade engagement to allow it to be a plunger lock manually operated knife. And this particular one is using a flipper tab to open the blade. So this knife swept the knife community like a hurricane, and everyone was in love with this absolutely easy to flick action. It's 75% ambidextrous, so if you're a lefty, you can still operate it with relative ease because the button is easily accessible to your index finger rather than the thumb, and nobody seems to be worried about that. But they don't provide a clip position for ambidextrous use. Now, this knife sold hundreds of thousands of copies. They're still reproducing it on a massive basis. They never took this model down like they do with some other models. When people go on YouTube and search for what's the best knife lock, there's still a lot of videos around from the times when this was a novelty praising this lock. Later, the community changed their mind because they realized in some situations is unsafe. You'll probably see some reviewers do like light spinal taps to prove that the lock is safe. On my channel, I subject knives to much more severe trials. Stand by and you will see what I'm talking about in a few minutes. Let's talk steel really quick. In a video about the Valor, I explain about why some steel's called surgical. And while some knife tubers say it's a misnomer or incorrectly used term, I disagree. This steel, in this case, 12C27, was specifically designed to be used as a straight razor or a scalpel steel. And the reason is it's quite stainless and it takes a really keen edge and it's really, really easy to sharpen. What it is not famous for, a really good edge retention. And what I mean by edge retention is the ability of the edge to resist wear and remain sharp. This knife only weighs 82 grams or 2.9 ounces, which is pretty light considering full liners construction, makes it more robust. And let's look at the size comparison. Here it is next to already mentioned Protect Malibu. And here's a larger Protect with a similar plunger lock called the Mordax. Here it is next to Benchmade Bugout. This is a full-length Bugout. And Ritter Hogue, or in this case Benchmade Griptilian, which is a slightly larger knife. And as it always goes, we have to throw in Paramilitary 3, which is an extremely popular EDC alternative for a lot of people, and here it is next to it.
Yeah, Spyderco Para 3 is considered by many to be a perfect EDC knife. And who am I to argue?
And another knife I wanted to show you here, it's a knife I reviewed a while ago. This is Swiss Tech, also purchased at Walmart. I believe this was a $30 knife, and it has a now somewhat obsolescent liner lock and thumb disc deployment plus the flipper. So similar vibe, different construction. How sharp is it out of the box? I have to say it doesn't feel very sharp. It feels less sharp than other Ozark Trails I tested out of the box. You can see and hear a lot of tearing going on, and it feels like, see how it doesn't want to, this is like the easiest thing to cut is the printer paper, and as you can see it's having difficulties getting in, and as I progress through the cut, yeah, something is catching on something. Gets a little better toward the tip. So we'll take a look under the microscope next and see what's causing the problem. Let's look at the edge. To do so, I use this USB-C microscope / camera that I purchased for the purpose of using it in these videos, but it since became an indispensable tool when I sharpen the knives. It has its own app, as you can see, and I can go to camera here and just look as I sharpen the knife. For example, I can just be peeking at the blade and connect it to my phone. I start every blade review with a tip condition, and this one is kind of sad. Let me try to show you, stabilize it a little. What I'm talking about, you can see right here, see how it's almost chrome plated shiny and the tip is rounded off. This tip is not pointy at all. When they strop the knife, they put way too much pressure on the blade against the stropping belt, and this is what you get. So if you look at the apex, I guarantee it's pretty well convexed or rounded off. Let's look from the other side. Well, this side looks a little better, as in less rounded off. So let's go like turn the knife so you can kind of almost see it in 3D. Yeah, so you can see that on this side, they right there, that line, it's almost like an extra bevel they put on the edge, and that's what makes cutting paper harder. So, and another thing, overstropping does reduce the time between sharpenings that you have to do. So I'm not a big fan. Let's look at the rest. I have to give them a compliment. They kept the grind angle consistent along the entire blade and from side to side. Same width, that's what I'm talking about. But they created a little bit of the recurve here. So instead of being completely straight, it slightly recurves, which for some people may mean a little bit more challenging sharpening. The grind of the blade is called hollow grind or concave grind, and while it's easier to produce than a flat grind due to the fact that you can do it with very simple antiquated equipment as opposed to flat grind requiring a more sophisticated factory equipment, even though it's easier to produce, it is preferred by a lot of knife people that put sharpness over everything else because it creates a very thin behind the edge geometry. And speaking of, let's measure that. Here are my digital calipers. Yeah, I'm getting 17.5, 18 thousandths behind the edge here. Some people prefer a slightly thinner geometry, but the advantage of the hollow grind is when you lower the angle, let's say you resharpen it with a slicer angle or more acute angle, you don't have to remove a lot of material behind the edge to get there because these two sides are almost parallel near the edge. Let's take a look at the fastener hardware. The pivot is T8 and the other screws are T6s. It should be easy to maintain this knife with this style of lock, as long as you have the right tools. I promote Hoto drivers on my channel. It really helps my channel if you select the affiliate link that I provide in the description and purchase this driver set. And it's a little less expensive if you order a pair. And sometimes you need a pair in case the hardware is not captive and you need two drivers to unscrew something. Alright, so I am going to take the blade out next so that I can test it for hardness. And to disassemble plunger locks, you have to remove. Here I'm starting on the clip side, where the pocket clip is mounted, as opposed to show side. The show side sometimes doesn't have the socket for the Torx wrench, and the pivot on all Ozark trails is captive, or at least Ozark trails that I've reviewed. So for that reason you only need one driver. Now you will remove the pivot and you could hear the bearings that come out. Oh, they're nylon bound. Are they ceramic bolts? This is my little flashlight. No, they're steel ball bearings that are bound in nylon, very fine bearings. And by fine I don't mean good, because I would actually prefer a more robust, something more robust. Here we go. Now you have a plunger. This is the spring. This is the liner. This is the button. Right now it's captive between this liner and the scale on the outside. You can disassemble it the other way. In fact, that's not what I normally do. Oh, and we have a garaged pin, meaning the stop pin is not a separate piece of hardware. It's kind of embedded into the blade. Is it machined into the blade or pressed into the blade? I would be very surprised. Let's take a look under the microscope here real quick. Why is it important? It would inform us what we're paying our money for. Can't tell. Is it machined right into the blade? And what's all this chipping around the... Ooh. Oh man, no, it's pressed, and when they pressed it, oh, is it cracks? Do they go through? That's the hole, right? Is it riveted in? Oh, I know. They pressed a higher diameter, so if I had to guess what's going on here, the diameter of the pin was this large diameter, and then they pressed it in, and as they did so, they nearly destroyed this blade. My goodness, look at this. This is going to be a point of failure, so we'll see when we test the blade. So here's an example of 3 different fits between the pin and the hole. So this is, let's imagine that's the blade material, and I'm giving 3 pins as an example. This first one, what engineers refer to is a loose fit. In other words, there's a lot of clearance between the hole and the pin, very similar to bolt and washer. It just slides right through. It's not meant to interfere between these two materials at all. The second example is what is called slip fit, meaning there's a little bit tiny clearance. We're talking 1 to
0.002 of an inch clearance per diameter. And when you insert a pin in a very tight opening like this, you almost feel like it interferes, but it actually is sliding through, and what you're experiencing, the feel that you get of interference, it's actually called bearing pressure. Bearing pressure between the walls of the hole and the pin. And here's an example of interference fit. Here what you see is the pin is slightly oversized, again by 1 to 3 thousandths of an inch oversized per diameter of the hole. And so when you are driving it in, and there are a couple of methods of doing it, when you're driving it in, it actually displaces the material and forms an extremely strong bond between this cylindrical surface and this cylindrical surface. And the methods for driving it through it could be just a simple hammering or hydraulic press downward pressure, or sometimes they call it friction interference fit when you are spinning the pin really fast and you're driving it through. The spinning creates a lot of friction around the entire interface, and that actually facilitates a better material cohesion in the end. And to me, that's what it looks like on this blade, except I think the pin was slightly oversized or the hole was slightly undersized. So the chipping probably occurred on the entry face. Another reason could be the hole is not 100% cylindrical, meaning there's a taper to it. And when they were driving through, they actually exceeded the ultimate strength of the blade's steel, and that's why you see cracking. So, is it really bad? Yes, it is. It's an evidence of poor manufacturing techniques. Is the blade going to disintegrate in your hand when you're doing something? The answer to that question is, I don't know. When you're stressing a heat-treated steel to that extent that it starts chipping and cracking like that, you are asking for trouble. But before we jump to the final conclusions, let's do the hardness test and then subject this knife to some of my resilience tests, and we'll find out if it will hold up in a pretty extreme situations. Before every hardness test, I validate the calibration of my Rockwell tester using this independently certified NIST compliant test block. It is serialized and it's marked to be at 61.99 HRC. HRC stands for Hardness Rockwell C-Scale. I set my machine zeroed out and apply the major force of 150 kilos to that test block via a diamond-headed penetrator. And here I get 62.1 HRC. We're well within calibration. Just to make sure, I will run the calibration verification again. Standard guiding the Rockwell testers allows a repeatability variation of 1/2 HRC, plus or minus. This time we got 62.0 spot on. As you can see, the machine is precisely calibrated. So let's go ahead and test the blade. This particular blade is a little bit challenging because there's not a lot of metal around the pivot hole and that embedded pin. So I'm struggling to find a good location. I am required to have 3 millimeters or 1/8 of an inch between my poke hole and the edge of the metal. I am also required to maintain 3 millimeter distance between each poke. And now I release the load and read the result. It's 55.6 HRC. I need to be sure, so I'm moving my test location to the flat above the primary bevel, where I have plenty of room to space the pokes correctly. According to Sanvic's datasheet, the recommended hardness for this steel in this thickness is 56 to 58 HRC. On this poke, I am getting 60.0 HRC, which is a little higher than expected. Looking at the datasheet, there is a path to this hardness, which entails a lower tempering temperature, but that in turn entails susceptibility to fracturing. On this poke, I'm getting 59.7 HRC. Let's do it one more time to get clean average. Here's a thought. A high hardness does not always mean better edge retention, because chipping can be just as detrimental to the edge retention as the lack of wear resistance. Again, we get 60.0 HRC, which for this particular steel is not necessarily a good news. So let's get into the torture testing and find out. So as you can see, there's a lot happening with this knife, and I reviewed the material that I filmed up to this point and decided that I edited it down to the length that
still contains all the important information that I wanted to share with you. But if I continue with this video, it will get too long. So I will leave you in a little bit of a suspense. I will put this knife under the immense stress of my testing in the next video. And because that video will then turn out a little shorter than I wanted, I'll circle back to the Valor and share some additional thoughts about the heat treatment and answer some of the questions that popped up in this video. So if you haven't seen the Valor video about Ozark Trail Valor, that is, please click at the link in the description and also in the pinned comment and take a look. I think Ozark Trail is a promising enough company, and it's worth learning as much as possible. And also, I think it may be worth to them to hear what the community has to say, so don't hesitate to comment. For now, I'm out. See you in the next segment.